let's continue looking at marginal analysis. We are going to look at this example. This is the total cost function that you're looking at here. C of x is x squared divided by 10 minus 3x plus 1. You're supposed to find the average cost, the marginal cost when x is 2, marginal cost when x is 15, marginal cost when x equals 50. Now, one of the aims of this is we're going to look at how these values compare with when you find the cost of the next item and then subtract what we have. We're going to compare using the derivative with calculating the marginal cost for one additional item. Alright, so let's look at it. We have C of x equals x squared divided by 10. So the average cost would be C of x divided, this is A, this would be C of x divided by x, which is x squared. This would be x squared divided by 10x when you divide by x, minus 3x divided by x plus 1 divided by x. So what you would get then is x divided by 10 minus 3 plus 1 over x. So there you have it, the average cost. Good. Now let's look at the marginal cost. Let's erase A. We're looking at B now. Part B. The marginal cost when x is 2. You're going to find the marginal cost first. Now, the way this is written, let's rewrite it. C prime of x, not P prime of x. We're not ready for the prime yet. C of x equals, this would be 0.1 x squared. Let's write it as something times x squared. 0.1 x squared minus 3x plus 1. Alright. So C prime of x then is equal to 2 by 0.1. This would be 0.2x minus, when you differentiate 3x you get 3. When you differentiate 1 you get 0. So this is what we have. Alright, so C prime of 2, when x is 2, what we get would be 0.2 by 2 minus 3, which is 0.4 minus 3, 0.4 minus 3, and that would be, that's what, negative 2.6. Alright, so that's what we have there, negative 2.6. Alright, now what about the other values? 15 and then 50. So what we have is C, this was B. The fact is, finding C prime of x, that was already done. Alright? So it's a matter of now finding C prime of 15. So C prime of 15 would be equal to what? 0.2 by 15 minus 3. 0.2 by 15 is what? It would be 3. 0.2 is the same as 1/5. So 3 minus 3. So it would be 3 minus 3, which would be 0. What about C? C prime of 50 would be equal to 0.2 by 50 minus 3. Remember, this is our C of x, right? This is our C of x. Alright, let's just underline it in a different color. This is our C of x. So what we are doing here is finding C prime of 50, which is 0.2 by 50, which is going to be 10. 10 minus 3 is equal to 7. Alright, so these are the values that we get when we differentiate to find the derivative, and that therefore does the cost, the marginal cost. Now suppose we did this to find the marginal cost, or it would be an approximation to the marginal cost. Here we say that what we do here is to say that we have part, by the way, why do I have two B's up here? Why I have two B's? B, C, and D. Alright. It should be C and this D. So let's rewrite that. This would be B, C, and D. Alright. What would be the cost when x is equal to 2? Let's calculate it in this corner here. C of 2 will be equal to 2 squared over 10 minus 3 by 2 plus 1 equals, this would be 2 2's 4 over 10 minus 3 2's 6, no, negative 6 plus 1. So it would be 4 over 10 minus 3 2's 6. So you have minus 6 plus 1, but minus 6 plus 1 would be minus 5. So let's just shorten it. This would be a minus 5. So 4 over 10. This is going to be the same as 0.4. So what we have is 0.4 minus 5, which will be negative 4.6. Now what would be C of 3? The next one. Remember, the marginal cost is the additional cost of producing one more. One more would be the third. We produce 2, let's produce a third. This would be 3 squared over 10 minus 3 by 3 plus 1. Let's partition. Alright, let's continue over here. We already have it in a different color. 3 3 is 9. 9 over 10 minus 3 3 is 9 plus 1. So this would be negative 9 plus 1 would be negative 8. So let's write negative 8 here. So it's negative 8. 9 over 10 is 0.9. So what we have is 0.9 minus 8, which is what? Negative 7.1. And then here, if we subtract them, we would say negative 7.1 minus negative 4.6. That would be the same as negative 7.1 plus 4.6. And what do you get for that? Negative 2.5. So we have negative 2.5. Alright. So here we had a C prime. The C prime gave us negative 2.6. But using the total cost function and subtracting two values gives us negative 2.5. Alright? So that's what we have. Now, later on, we will look at the graph and try to explain the reasons why the difference and why the difference is like that. Let's calculate the two values now for 15 and 16. So C of 15, at 15 it would be 15 squared over 10 minus 3 by 15 plus 1. Now 15 squared over 10. In that case it will be 15 by 15, which will be 225 over 10. But 225 over 10 is 22.5 minus 15 trees is 45. So we have negative 45 plus 1, which will be negative 44. So what you get is really 22.5 minus 44, and that will be negative 21.5. So you have negative 21.5. Now what about C of 16? C of 16 would be 16 squared over 10 plus 3 by 16 plus minus 3 by 16. This would be a minus 3 by 16 plus 1. So this would be 16 squared is 256 over 10 is 25.6. So we have 25.6 minus 3 by 16 gives us 48 minus 48 plus 1. So 25.6 minus 48 plus 1 would give us negative 21.4. Called negative 21.4. Now that is C of 16. Negative 21.4 minus negative 21.5. Now, what we have is negative 21.4. So, negative 21.4 minus negative, but it would be plus. The minus negative would be plus 21.5, and that would be 0.1. Right. Now at 50, let's calculate what happens at x equals 50. Now see at 50. After that we'll do 51 and subtract them. C at 50 is equal to 50 squared over 10 minus 3 by 50 plus 1. So this would be 50 squared 2500 over 10. This would come back down to 250 when you divide by 10. Alright. Minus. So what we get is 50 by 3. 3550. Negative 150 minus 150 plus 1. What do you get when you work this out? You have 250 minus 150 plus 1. That gives you 101. Alright, so 101. Let's calculate it for 51. So C at 51 would be 51 squared over 10 minus 3 by 51 plus 1. So that would give us 51 squared over 10 will be 260.1. So 260.1 minus 3 by 51 and that would be 153 plus 1. So what you have is 260.1 minus 153. So that's minus 153 plus 1, 108.1. Alright, we have this and this. When we subtract them, 108.1 minus 101 is equal to 7.1. So here we have 7.1. Alright. So let's erase these. This was, alright. So in red, I have the approximation, negative 2.5. Right? In blue, I have what I get from using the derivative, which is a more accurate value. Alright. Now, let's look at the graph of this function. X squared over 10 minus 3x plus 1. X squared over 10 minus 3x plus 1. That x squared over 10 minus 3x plus 1. Alright, that's a graph. Let's make the graph a bit thicker, and I want to see the formula on it. Okay, good. We have our graph now. Now, at 2, the accurate value is 2.6. The approximation, negative 2.6. The approximate value is negative 2.5. Negative 2.6, negative 2.5. So let's write those down. Negative 2. Oh, let's change the colors here. Negative 2.6, and in red, negative 2.5. Alright, good. Now, let's zoom in a bit and see what's happening at 2 and 3. So we have 2 and 3. Good. At 2, this point here is the intersection of the graph at x equals 2. Right here. At 3, this is it. Now you notice that both gradients are negative, because the gradient of the line would go down this way, right? Or the tangent would go this way, so the gradient is a negative gradient. Alright, now let's erase that. Here, at 2 you have this. At 3 you have this point. Now if you should draw a line between the 2 and the 3, if I exaggerate it, it would be something like this. The real gradient from differentiation would look like this. But the gradient of a line through both points would look like this. Alright? Now, we had negative 2.6. The blue should have been negative 2.6. Why? There. Right, negative 2.5. This was negative 2.6. Right. The one that we got, the line that we got. Alright, let me erase this and redraw it. If I should exaggerate the graph. The line that we got from differentiation, I'm trying to make this line straight. Not very straight, but we're trying. oh no, would be somewhat like this, right? But the line from comparing the two values, one here and the other here, would look more like this. So both lines are running from upper left to lower right, so they have negative gradient. But the line that we get from differentiation would be more steep. It would be a steeper line. It looks a bit messy here, right? But you get the idea. Let me see if I can improve what's going on here. So this would be the line. It's steeper, all right? And the red line, the line that we get from approximation, would be less steep. And this is the reason why. The derivative is finding the derivative at this point. Right? It was 2. I need to shift back the graph to where it was. It was at 2. Right. So, in any case, what happened on the graph is that you have a curve here. And if you had 2 here, if this was below 2 and this was below 3, when you find the gradient at 2, this is the line that you would have, negative 2.6. When you find the gradient at 3, the gradient of a line passing between 2 and 3 for the total cost function, this is the line that you would have. The line, the red line, would be an approximation because you're finding the gradient of a line that passes between 2 and 3. And it would be less steep. This answer here is an approximation, and it is less steep. Right? Just to give you an idea why you have a difference between when you differentiate and when you find the cost function for this value and then the value after. Let's look back at this. 0 and 0.1 at 15. Let's look at what's happening at x equals 15. Alright. Where is my 15? This is a 15 line. Alright, let's trace it and not lose the line. Alright, this is what's happening at 15. Good. Now, this is the line at 15. Right? From what we did earlier, you can see that it is the axis of symmetry and the value is 0. The derivative is 0. Alright? Now, when we approximated and found what happened at 15 and what happened at 16 and then subtracted them, what we were really doing is this. This is the 15 line and this is the 16. If we should draw a line that goes through the 15 and 16, we would get a line like this, slightly sloping upward as we're having a positive gradient. However, the fact is, when we differentiated at 15, we get 0 because it would be a horizontal line. So it will be 0. So you see, at 15, you had a positive gradient. Slight positive gradient, 0.1. At 15, using derivative, we get 0. But at 16, when you find the cost at 15 and then the cost for the 16th item and subtract to get the additional cost, you get 0.1. But the thing is, the more accurate value is 0, at 0, right? The fact is, these items might not be countable in 1, 2, and 3. It could be per hour, services per hour, and you have a fraction of an hour. It could be selling pieces of material per meter, and you don't necessarily sell at one additional meter. It could be half a meter, 0.1 meter. If we sell 0.1 meter more, what would be the cost? Additional cost. So using the derivative is giving you a far more accurate value, right? Now here at 50 we have 7 and then 7.1. Let's look at what happened at 50. Let's erase these things first. We have to zoom out and look at the 50 line. See if we can find the line at 50. Alright, this is our 50 line right here. Let me go up and not lose it. I don't want to lose the 50 line. Right, still seeing the 50 line, haven't lost it. Alright, this is the 50 line. And what happened? This value here will be at 50. So we have 50 and 51. So right here, where the line crosses the 50 line, and this is where the line crosses the 51 line. Alright? Now, what you would have between 50 and 51? First of all, you see that the line is quite steep here. That's why you get 7 point something as a gradient. But at 51, what you would have is a higher gradient. If you find the value at 51 and then 50 and find the curve that cuts through them, the gradient would be higher than the derivative at exactly 50. Alright? So that is just to give some understanding as to exactly what is happening. Why is it that when you find marginal cost using derivative, differentiating, you get a slightly different value from when you say what is the cost of this item and then what would be the additional cost of the next item by finding the cost of the next item and subtracting them. Alright? So in this case now, if it is, for example, suits that you're making, right, the marginal cost will be the cost of the next item. So at 50 items, then the 50 suits, then the 51st suit. What will be the marginal cost of the 51st suit? But if it is the length of clothing material that you're selling, and you always sell 50 meters, and you might say, what is the marginal cost of 51 meters? What would be the margin of producing 51 meters? What would be the marginal cost of producing, well, did I say selling suits? What would be the marginal cost of producing 50 suits and then the 51st suit? That's what I should have said, right? When you're selling, you're looking at making money, not spending. But when you're manufacturing these suits, you actually have to be spending money to make them. Now, if it is clothing material that you're manufacturing, then you would have to say what will be the marginal cost. Well, you could say what is the marginal cost at 50 items by saying if you sell, 50 meters if you sell 51 meters. But then you don't have to go in whole numbers. You could say, suppose, or if we manufacture 50.5 meter, 50.3 meters, 50.1 meter, right? So that is where the more accurate value using differentiation would come into play. Alright, so yes, that is it for this video. I'll see you in the next video then.